Students, let us do a problem based on the jury stability test. So, let us see the question. Check for stability of the sampled data control system represented by the following characteristic equation. Z cube minus 0.2 Z square minus 0.25 Z plus 0.05 equal to 0. So, you are asked to find the stability of the sampled data control system and its characteristic equation is given. So you can use jury's stability test to find the stability of this sampled data control system. So first of all, stability analysis by jury's stability test, and here it is given that f of z. So you can represent f of z equal to z cube minus 0.2 z square minus 0.25 z plus 0.05. So that will be equal to 0, and here the order is 3, that is n is equal to 3, and corresponding to order 3, the corresponding equation for f of z is a3z cube plus a2z square plus a1z plus a0. That is the general form for the characteristic equation. So that will be equal to this one, okay, that will be equal to 0. So in this you can find a3 is equal to 1, a2 equal to minus 0.2, a1 equal to 0.2 minus 0.25, and a0 equal to 0.05. So by comparing you can find these coefficients, okay. Let it be that. So you know that in the case of jury's test we are checking necessary condition for stability, and whenever it is satisfied or when the system is stable, then you have to go for sufficient condition for stability. So first is the necessary condition for stability. What are the condition? Condition is f of 1 should be greater than 0 and minus 1 raised to n f of minus 1 should be greater than 0. That is the necessary condition. So let us check f of 1. So put z equal to 1 in this equation of f of z. So f of z is this one. Whenever you are putting z equal to 1, you will be getting the value 0.6. So you can ensure that f of 1 is greater than 0. So first condition is satisfied. Next is minus 1 raised to n f of minus 1. So here n is 3, order is 3. So minus 1 raised to n is minus 1, and f of minus 1 is obtained by putting z equal to minus 1 in this equation. So you will be getting 0.9. So again the second condition, f of minus 1 is greater than 0. So these two conditions are satisfied. That means we can say that the necessary condition for stability is satisfied. So next, what is the step? Next we have to check the sufficient condition. There are two methods. Here we are utilizing the first method for finding the sufficient condition for stability. For that we have to form a table using the coefficients of this f of z, and I have already said the coefficients are a3, a2, a1 and a0. So here we can first form the table. You know that in the case of jury's test the number of rows in the table will be 2n minus 3. Here n is 3, so the number of rows will be 3. So first of all we can mark the number of rows, and then again we can write the column elements, that is z raised to 0, z raised to 1, z raised to 2, z raised to 3, since it is a third order equation. So we can write in the first row the coefficients will be written. So the coefficients a0, a1, a2, a3 are written in the first row, and in the second row the reverse order of the first row, that is a3 comes first, then a2, then a1, then a0. So first two rows can be easily formed. Next third row we have to find out the entries in the third row will be b0, b1, b2. We have to find b0, b1 and b2. The equation, there is a separate equation for finding b0, b1 and b2. So b0 will have an equation. B0 will be equal to for finding b0 we are using these two elements in the first column, that is a0, a3, a0, a3. In the second element will have a form that will be equal to an minus k and ak. Here n is 3, k is b0, k is 0, an minus k means a3, and ak will be a0, k equal to 0. So this is the equation. So you have to go through the procedure for the jury's test, then only you can solve, then you can find the equation for b0, b1 and b2. So next you can substitute for these values a0, a3. a0 is 0.05 and a3 is 1. So this is 1 and this is 0.05, and its determinant value will be minus 0.9975. Similarly b1 will have an equation, bk also have the equation, or b1 will have the equation We know that bk has the equation a0 an minus k ak. Similarly, so we will be getting b1 will be equal to this row. First column is same, that is a0 a3, and the second one is an minus k. What is an minus k? Here n is 3, k is 1, so a2, and this is ak element. Ak means here k is 1, so this will be a1, so a2 a1. So you can, when you are checking through this table, you can find that the second element b1 is obtained by a0 a3 in the same manner. You can write in the same manner, and the next column will be a2 a1 order, a2 a1. Similarly, in the case of b0 also, a0 a3 is written same like this, and the second one is a3 a0 in the reverse order. Okay, a3 a0 in the reverse order. Similarly, b2 can be found out by a0 a3 in the same manner, and in the case of b2, a1 a2 will be taken. Okay, so that is an easier method. So you can find the determinant, and you will find different entries like this, and next you can write the elements of b0 b1 b2 a0 a1 a2 a3 etc. in this table. So you will get the table like this, and here once you form this table, you have to check for n minus 1 condition. What are the n minus 1 conditions? N minus 1 conditions are modulus of a0 less than a3, that is its modulus should be less than this one a3, and second condition is modulus of b0 greater than modulus of b2. b0 is this one, b2 is this one, so that also you have to check. Okay, this is the n minus 1 condition, that is we have to check two conditions. a0 should be less than, modulus of a0 should be less than a3, and modulus of b0 should be greater than b2. b2 means this is first element and this is last element, so we have to compare the modulus values of these elements. So once you can see that the first condition is satisfied and second condition is also satisfied, so sufficient condition is satisfied. That means here necessary condition as well as sufficient condition is satisfied. So we can say that the system is stable. So the necessary and sufficient condition for stability are satisfied, hence the system is stable. So this is the way we have to apply Jury's test for testing the stability of sampled data control system. So it is an important question. It is asked for university question of KTU. Go through the problem once again. If you have any doubts, you can ask me. Thank you.